Hey everyone, welcome to Observe 2020. I'm going to be talking about tracing IoT event streams. This is, I guess, a case study. I'll be circling back to a lot of the things that Daniel talked about in our specific, story of how we implemented tracing in our system. Before I get started, I should tell you a little bit about me. Marc Zbyszynski. I'm a director of software engineering at GCP Applied Technologies. No affiliation to Google Cloud Platform. We're a very old chemical and building materials company that has been branching out into IoT services for construction and things like that. Been a developer for a long time, an engineering manager for a long time. Been working on backends for industrial and automotive IoT systems for the last 8 years. And here's a photo of me working with helping a junior developer through a very particular and scary problem. All right, so here's our use case. We at GCP Applied Technologies thought it would be cool to put a computer on a concrete truck. Why would we do that? Well, it turns out that making concrete is sort of like making a cake. You need all the right ingredients. You need to mix it properly. You need to add the right amount of water, spend the right amount of time with it. And if you do everything right, you end up with this sort of miracle material that will last hundreds of years and will hold up your house or your bridge or whatever you want. If you do anything wrong, you can have a suboptimal material where it's, when winter comes by, it might start to crumble or crack, or heaven forbid, it could not be as strong as you think it is and it couldn't hold up what you need to do. So if we go back to this cake analogy, what we have built with this Verify system is a magic mobile cake making machine on wheels. You take your ingredients, you throw them in the truck, you download the recipe, and you start driving. With our sensors and a whole lot of math, we figure out what's going on with the concrete inside the truck. We tell the driver what to do. We automatically add water and other fluids if we need to. We use GPS to figure out how close we are to the delivery site. And so every time when you get there, you have a perfectly mixed batch of concrete that's all ready to go, totally within spec. Not only that, but we have collected data on everything that happened to that concrete since it was entered into the truck. And we have reports and sort of a lineage to make sure that nothing was actually done to that concrete that would ruin it or compromise it in any way. And yeah, so that is what we have. And it's not concrete that comes out. I mean, it is concrete that comes out. It's not cake, which is less exciting. But if anyone wanted to take that idea and build a mobile cake making machine, then that would be fantastic. So you should feel free to run with that. That's a freebie. So now after, this is a little bit about the product that we are supporting. Now I can sort of jump into what I really am here to talk about, my feelings. Many of you might be familiar with the term FOMO, or the abbreviation FOMO, fear of missing out. I don't have fear of missing out. I'm too old. I know I'm missing out and I'm okay with it. But every day when I log into my system, I have an intense fear of missing events, which I guess would be FOMI or foam, maybe. I'm not sure how to pronounce it. And let me show you why here. This is a simple sort of system diagram of what's going on here. And as you can see, there are lots of boxes and arrows. We've got data coming in from third-party software from our concrete trucks, as well as from mobile and web platforms. And it's moving around. And we've got a lot of arrows here. As an example, we might have, I alluded before that when you're going to make a cake, you need a recipe. The same thing when we're delivering concrete, each time it's a little different. So we have this recipe or mixture coming from a third-party software that's actually at our customers' on-premises site. So that comes in through our REST API into Kafka. Kafka's our event streaming platform that we're sort of built our system around. It bounces around inside Kafka where the message and the event is augmented in a bunch of ways. And it goes back out into RabbitMQ and then down to the truck. And this needs to happen within a few minutes of when the concrete is actually loaded for our system to function properly. And when it doesn't, there's a significant business impact to ourselves and our customers. In a nutshell, We have a complicated branching system with a lot of services, data from multiple sources that has to be correlated. The delivery of message is critical, timely delivery is critical. There are also lots of less critical messages coming in, muddying the waters. And there are many places for an events to get lost, hence my fear of missing events. We do have extensive monitoring and metrics gathering and alerting using Prometheus and Grafana, tools like that. That does leave some lingering questions. You know, I'm very sure that my services are all working properly, and if anything major happens, I'll know about it. But I have a few lingering questions, namely, what is our end-to-end throughput? And also, are any messages being lost? And this is where tracing can help because it follows the data and not the services, as Daniel mentioned. And just to review what tracing is to me, how I see it is that each event or request or message comes in, it's assigned something to identify it as a specific trace. And that could be, you know, sort of specific to each provider. Then each service that is receiving that message or process is going to report some activity to it, to that tracing ID. Hey, I just got trace 123. I'm going to transform it, and that takes 20 milliseconds, for example. That's a span. We have a tracing service or provider that collects all that data and gives you access to it via dashboards, reports, whatever. It's not a replacement for other types of monitoring. It just fills in these gaps that I mentioned. And here's a quick screenshot from Lightstep, which is the tracing service we use. And you can see here at the top, there's a timeline of this event when it first came into our system. It was processed, and then at the end, it was completely processed on the right there at 167 milliseconds. Down below, you can see these specific spans or operations and how much time they each took. One thing I also want to point out, which I'll get back to later, is you'll notice there's a big gap here of white space in our timeline. This is actually when an event is sitting in Kafka waiting to be picked up by a downstream producer. So that's also something that is sort of important to us. Now, when we decided to jump into tracing and see if it could actually help us with our system, we had some priorities. Obviously, we wanted it to work with our stack. We're a Java shop. We use Kafka extensively. We did not want to have to change our stack to get tracing benefits. We also wanted to do as little work as possible to set it up and also to maintain it. We're a very small team, and as you know, Liz alluded to, anytime in her talk at the beginning, anytime that we're spending not working on optimizing our business code is sort of a lost opportunity. Also, I would say if you notice anything I missed in this presentation or any errors that I have, it's actually me meeting this requirement of doing as little work as possible. So that's what success looks like. We also want to be able to detect errors even when they're very rare or a very small percentage of traffic. We could have some condition that only happens once a week or only happens once a day. We wanted to be able to find those error conditions when they did occur. We also needed it to work with a local development environment. We have extensive sort of Docker setup, and we didn't want to compromise that for our developers to slow them down. And we also didn't want to spend any money to get started because we weren't sure if it was going to work or not. So we first looked at a couple different tracing APIs and tracing providers. And this was about a year ago. It was before OpenTelemetry was announced. So OpenTracing was one of the projects that went into OpenTelemetry. You can see here, there's a bunch of providers. This is not an exhaustive list. This is just a couple that we looked at. And we didn't see too much, at least in the Java world for us, there didn't seem to be too much difference between the Zipkin API or the tracing API in terms of support or Open Tracing API. We also did look at Amazon X-Ray. We are an Amazon shop, and we thought, hey, maybe it would be easy to just use Amazon's tracing provider. We dismissed that one pretty quickly because at the time it seemed like there wasn't as much work to do, work done. So it would have been a lot more work for us to implement that, was sort of there wasn't a lot of existing libraries or examples or cross compatibility for us. So we eliminated open tracing. We weren't really sure whether to go with Zipkin or we eliminated X-ray. I'm sorry. We weren't sure whether we wanted to go with Zipkin or open tracing. What made up our mind were the instrumentation libraries. So an instrumentation library is an existing project that instruments some low-level primitive or function within your application, and you can sort of drop them in and get that tracing. For example, you could have a instrumentation library for all your SQL queries. You say, I'm just going to add this library, and then a span will be added anytime that I make a SQL query anywhere in my application. And this is where open tracing really shined. For us anyway, there were a lot of Java libraries that were already instrumented in open tracing API, and almost all the tools we were already using had instrumentations. There was also a thing called a Java agent. That's the project Open Tracing Java Special Agent, and that turned out to be really useful for us as well, and I'll talk about that in a second. Once we had decided on the API, we actually had to do some work. And there are a couple different flavors of instrumentations that we did. The most simplest is actually just to add the tracing to your code. This does require some work. It lets you add specific traces and tags that are specific to your business or your use case, so that's very nice. The drawback here is that it can leave some blind spots. You may make a span that is too high level, that has too much going on inside it, and you can't really tell, which step inside a span is contributing to latency. Or it could be too granular. Maybe you create two spans within your application, but there's actually a gap that you've never thought would cause any latency and you're not really aware of. So you didn't write a span for that piece, and maybe that is causing latency. You just wouldn't necessarily know. And then here's just an example of the Java code. This pink part is the code that actually runs your application. You just do a little bit to set up your trace, and you can catch an error and tag it, and then wrap up your trace at the end. Another flavor is to use those instrumentation libraries that I mentioned. There's still a little bit of work. You usually need to modify your code in some way to take advantage of the instrumentation. Depends on the library. It's also not customizable. So there's a set of spans and tags that the instrumentation library already provides, and you just have to use those. The good part is that you can reduce those blind spots that I mentioned before, because you're instrumenting one whole list of functionalities. Like, for example, you're adding spans to all your HTTP requests or all your SQL queries, things like that. And here's just an example of a pull request where we added our tracing to all our HTTP requests. All we had to do was add this new dependency and then change the class we were using to take advantage of tracing. So that was pretty nice. The third way that we implemented tracing was with this Open Tracing Java Special Agent. This is a library that takes advantage of the Java Agent API, which allows you to sort of run a piece of code along with your own application and gives that piece of code access to the internals of everything that's going on. A very powerful, potentially scary API, but it's really great in this case because you can make no changes to your Java application. You just start it up along with this Open Tracing Java Agent, and inside the Java Agent package is all those instrumentation libraries that I mentioned. And on startup, it just goes through and says, hey, are you using SQL queries? Great, I'll instrument that and add spans anytime you do that. Are you using Kafka? Okay, I will write spans anytime you produce or consume a message. Are you using HTTP? I'll add spans to that, and so on and so forth. So it's a great way to get started without any code changes. You can just plop this special agent on there and see what traces it gives you out of the box. For us, it was also great because we have parts of our app stack that are actually third-party code. We don't modify that code at all. We're interacting with it with passing it configuration data, environment variables, and also sending it data in the format it expects. And this allows us to add tracing data to that. Our events are flowing through these third-party tools, We don't have to lose the tracing observability within that tool. And we also don't have to do anything annoying like forking the Kafka Connect to add in our own tracing data. So we're actually using all three of these in production right now, all three of these flavors of tracing. We also had to select a tracing provider. That's the thing that's going to aggregate all your tracing data and let you look at it. We started with Jaeger, which is an open source tracing service or tool that was developed by Uber. It's really easy to set up locally. We just had a Docker container we would run, drop it into our development environment. We didn't have to deal with any sales calls or anything. We could just get started playing with it. And that got us pretty far. We were able to add tracing to our whole stack, all our different services, and validate that the traces were being correctly attributed, and see them show up in Jaeger. So that was great. There were some limitations. There aren't too many reports, at least at the time we were using Jaeger. You could sort of watch traces coming in and drill into specific traces, but that was about it. There is also, Jaeger does do sampling. It's configurable, but the worry there was that I mentioned we had this requirement of trying to capture some errors or problems that might occur very infrequently. And we were worried that sampling could potentially hide some of those low frequency problems. But the deal breaker came for us when we started involving our SRE team more about deploying this into production. And Jaeger does have a lot of components under the hood. There's a Cassandra cluster, some other things like that. And we didn't really want to take on the work to have to maintain all those in production. And that led us to sort of look at tracing services, tracing providers that would handle all that for us. That brought us to Lightstep, which is who we use today. They've been fantastic. I don't really have any cons that I could think of, but a bunch of pros are, it's been easy for us to manage. We deploy a Docker container called a satellite that collects the tracing data and makes it available to Lightstep. They have a ton of features and reports. They're rolling out features all the time. They don't sample, so they're looking at every trace, which is nuts, but that's what they do. And they also have great customer support and success team that we've relied on heavily. So that's been great. And you should definitely talk to them some more, in the Lightstep booth channel. But we had some challenges when we were implementing tracing. Two in particular I wanted to highlight. One is the tracing identifiers. This is something Daniel also mentioned in his presentation. In order to connect the spans for a specific trace, you need to have a tracing identifier. These are in the open tracing spec. These are proprietary for each tracing provider. There also isn't a lot of documentation that we found about what these were. So we had to do a little bit of reverse engineering. For example, we had a message that was put into RabbitMQ, and we had a span that did that. And then we had to take it out of RabbitMQ and put it into Kafka. And we had various applications that were doing that. When we first ran it, it looked like totally disparate spans that weren't connected to the same trace. We had to inspect the message. We realized, hey, there's some headers on this RabbitMQ message that have the word Jaeger in them. Why don't we copy those over to the headers of the Kafka thing, and maybe that'll work. And that connected those traces. So we had to make sure we were preserving those tracing identifiers. And when we switched to Lightstep, we had to go through that same process because the identifiers are different. The good news is that the open telemetry spec and the WC, the specification that Daniel mentioned fix this problem, or at least make it not proprietary. So it's part of the spec, and there's also a lot more documentation around it. So I think if we were to start today with open telemetry, we may not have had this problem to the same degree. The other issue we had was that there is a lot of Java magic stuff going on. The Open Tracing Special Agent is doing a lot of magic things. The instrumentation libraries themselves are doing a lot of magic things to actually get into your code and find all those cases where you're using a specific operation. And we had other pieces, other libraries that were also doing magic things, and sometimes they would conflict with each other and cause very strange errors. So that was a challenge, but we worked really closely. Lightstep was a great help. They even facilitated some patches to some of those open tracing instrumentation libraries for us to fix our specific issues. So that's been great, and everything's working now. I want to take a few seconds to just show you a couple shots of our production Lightstep. And you should talk to Lightstep to get a full demo, because there's way more than I have time to show you here. But this is a query I ran this morning that shows all the different spans we have coming in. This is a latency histogram of how long, how much time each span is taking, and you can look at that a week ago, a day ago, a year ago, etc. You can you can see correlation data on all these spans on the right side here, and you can drill into a specific span and look at it. And here's one from our application. You can see there's quite a few spans within this trace. We have a message coming in from a vehicle that is going through our legacy system and then into Kafka Connect and so on. And each of these spans we have a combination of all three of those flavors I talked about. So some of them are coming from the Java special agent, some of them are coming from instrumentation libraries we added directly to our code, and some of them are just spans that we created ourselves. I like the JDBC one here because you can see it adds a fair amount of information to the trace. It actually puts the SQL query. And if I was concerned about this SQL query, or I noticed an anomaly, I can just click here and see all the spans that are using this exact query and what the latency histogram of it. And this is the data that's happening, flowing through the system right now. Lightstep also allows you to create what they call a stream, which is a query that you provide, and any spans that meet that query are added to the stream, and they're kept over time, and you can see sort of a long bit of data. And this is a specific stream that we have that captures errors. There should never be any errors in our system, so of course here are some errors that we have. And you can look at the specific errors in the graph, mouse over each one and see each span. You can drill into these at the bottom. We also show them here. And you can see what those are. So just to wrap up, we had a few sort of open issues that we haven't quite figured out yet. For one thing, we have some parts of our event processing that are batches, and we don't currently have a way to follow a trace into a batch. For example, we may have 10 events that are all written to the database in one batch. We don't currently know of a way to tell open tracing, hey, these 10 different traces are all participating in this one event. Another problem we have, or challenge that we still haven't figured out, is we would like to be able to trace the gaps between spans when, for example, in our system, a message is just sitting in Kafka. We don't currently have a way to highlight the latency there, at least in our tracing implementation. So that's something that still would be cool. And then lastly, the end-to-end latency is still something that worries me. I don't have a good way to see how long it's taking events from when they first enter to when they're completely processed. I can definitely see that on an individual span, but I can't see any kind of aggregate data over time or look at a histogram of my end-to-end tracing process. So that's another thing that would be really great to have. And thanks again for listening. I'll be taking questions in the Slack, and thank you very much. Thanks, Paul. You can take it away.
Absolutely.